Hello SGD, Sacred Geometry Decoded. This will be part 17 in the series, but I'm going to give this one a more clickbaity title because it's quite important, if I do say so myself. So we're going to link the pyramids of Egypt. Rather than examine one or compare two, we'll show how there is a very beautiful geometric and later astronomical link, musical link, arithmetic, essentially the four liberal arts. But so let's focus on Egypt, Thoth and Chesed. They're the gods of science and record keeping, gods of astronomy, architecture, math, geometry, and weights and measures. Weights and measures, of course, being inseparable from science. It's the basis of it, to take measurements, to weigh and to make observations, and through math and geometry to bring those together. Well, the astronomy, or especially the architecture of these pyramids, is a holistic series of connections. And so before we begin, I'll let you, just rather than me put the points down, fact 1, fact 2, fact 3, consider the fact that each one of these facts will bring us increased probability, or let's say increased improbability, that this is all a coincidence. And so just to focus on one or 2 points, well, the skeptic might say, well, that's a coincidence. So let's look at this as a series of connections, and the level of improbability of these being a coincidence approaches infinity to 1 against. So geometry, measure, especially through length, but also area and also volume is in the 3 dimensions. That will be incorporated in this as well. But geometry is the first of the sciences, a primary science, and the geometry of the pyramids will exquisitely, beautifully, wonderfully link together through measurement also, and geometry. Now, in this particular part, I'll be looking at the Fibonacci and the Lucas numbers. Fibonacci numbers, they're pretty famous. So we begin with 1. 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. These are the Fibonacci numbers. We also have the Lucas numbers, which begin 1, 3. Now, because if we began at 1, 2, we would just repeat the Fibonacci sequence. So the next sequence up is the Lucas numbers. 1 plus 3 is 4. 3 plus 4 is 7. 4 plus 7 is 11. 7 plus 11 is 18. Now, you can write them down as numbers, but you can also represent them as these spirals. And so it's arithmetic and it's geometry. And this arithmetic and geometry will connect to music and to astronomy, the Quadrivium, the ancient sciences. So again, now whether it's Rome, India, or all across all cultures, cross time, across the world, we have this fruit of life, flower of life pattern. This is at the Osirion in Temple of Abydos in Egypt. Some attempts have been made to say it's, well, I don't know why, but anyway, let's leave that to the side, but it is there. And however it was drawn in there, now I would just say with carving, but let's, all those issues aside, the geometry is a beautiful geometry. It's the essence of Euclidean geometry. It's the essence of sacred geometry. Now, my channel is called Sacred Geometry Decoded, and the reason I say decoded is because sacred has all sorts of implications. What we have is Euclidean geometry, provable, tangible, testable, unquestionable geometry is embedded in this particular pattern. And from the seed of life, the flower of life, and the fruit of life, it all emerges from the Vesica. Now, the Vesica Pisces is the essence of geometry. So let's imagine the first person to invent a compass for drawing circles. You draw one circle. Where do you put the next circle? Now, you could put it randomly somewhere else. The Vesica is intrinsic. It's demanded that you would place the second circle on the edge of the first. That's just, that's just logical. Where else would you put it? Just some random point? Would you put it a meter away? Would you put it a mile away? No, you put it on the edge. And this is the inherent logic of this also leads to beautiful arithmetic, the geometry, the first of the sciences. Simplicity is the ultimate sophistication. Leonardo Da Vinci, throughout this series, has been talking about the Vitruvian Man. Now this is Now, complexity is the repetition of simplicity by an unknown geometrician, but this very complex image is just the repetition of simplicity. And just like with the flower of life, you just repeat the Vesica. Every time the circle intersects, you draw another circle, and then you draw another circle. Then where they cross over, you draw another circle. This is built into nature, essentially, and it's the essence of wonderful, beautiful geometry. Now, speaking of Leonardo da Vinci, one of his quotes, and this might be an internet quote, but still it's very valuable: learn how to see, realize that everything connects to everything else. And we have an image of the seed of life, which is just a series of Vesica Pisces. One circle surrounded by 6 others, creating a perfect hexagon. One of the beauties of nature, why beehives, for instance, is the most perfect, the most efficient form of structure. Nature insists upon it. And well, just Leonardo da Vinci studied the fruit of life, seed of life pattern, and there we have an example. And there we can just see the 6 petals which divide into a hexagon. That's exactly what's happening in this geometry as well. Euclid's Elements. Euclid's Elements is the most important, most published, most universal book in history. Every culture, every religion includes Euclid's Elements. It doesn't matter where you go, because it's the laws of geometry are universal. And book 1, proposition 1, literally the first page of Euclid, we have a Vesica to create an equilateral triangle. Now, if I was to create another point here where the circles intersect, and E, that would also be an equilateral triangle, and the ratio of the small to the larger would be the square root of 3. The square root of 3 is built into the Vesica. It's pure math, pure geometry. It's a fundamental, intrinsic law of the cosmos, of the universe. Now, Vitruvian Man will be referring to this. This is a drawing by Leonardo da Vinci based on the Roman architect Vitruvius's book, 10 Books of Architecture, which is a essential read if you're even remotely interested in ancient history. Unfortunately, there is a movement of, okay, I'm not going to go into it, but the 10 Books of Architecture describes ancient technology, ancient geometry, ancient philosophy of architecture, and the important concept of man is the measure of all things, as said or attributed to Protagoras. Man is the measure of all things. The units of measure are based on a man, and we can find this in cross-time, cross-cultures, across the world. Geometry quotes. Music is geometry in time. Geometry is the knowledge that appears to be produced by human beings, yet whose meaning is totally independent of them. Where there is matter, there is geometry. Now, geometry, all the esotericians, all the hermeticists, all the greats of the past were all geometricians. This is simply a fact, whether it's Plato, Pythagoras, Kepler, in more recent times, even Steiner, Euclid. Geometry is the primary science. Albrecht Dürer as well. Without geometry, there is nothing. Let no one ignorant of geometry enter my door. This was written above the academies of Plato. Similar was, well, at least philosophically, the academies of Pythagoras also included those as well. But back to the Fibonacci and the Lucas numbers. Now let's begin with the Vesica, which is at a 3:2 ratio. 1, 2, 3, and 1, 2 height. Now that's just, there's a Fibonacci numbers. Now the Fibonacci spiral, the beginning of it, one of the best ways to begin the Fibonacci spiral is with the Vesica. Even the first part of a spiral is defined by this part of the Vesica. It just is. Now, to begin the Lucas numbers, we simply begin with a Vesica, but we cut it in half at a 1:3 ratio. 1:3. I'll put a link in the description how the pyramids of Giza, and this will link to all the others as well, but let's just the 3 most famous pyramids at Giza, via the Fibonacci and Lucas numbers and Pythagorean music, we can draw these in a lovely geometric way. Now you could do it with arithmetic, writing it down in numbers, but you can the best way to express this is through geometry, to draw it. Okay, so 3:2 ratio of Vesica, which is a 3:2 ratio incorporated in the Fibonacci numbers. 3:2, Vesica we see just as an example. Alright, now we also have the 5:8 ratio. This would be 5 high to 8 wide. Now to the Lucas numbers. This particular spiral is 11 wide by 7 high. 711, just like the convenience store. Then we have the 7:4 ratio, and we have the 4:3 ratio. Very simple geometry, which of course that's also another reflection of the Vesica Pisces. So we have these inherent geometry. Now also the Vesica begins with, the Fibonacci 1:2 ratio, that will also be embedded in the pyramids, very important. So with this very simple spiral, very simple arithmetic, we have the basis to understand essentially all of the pyramids of Egypt, at least the great pyramids, those most famous ones, such as the Menkaure Pyramid, the Khafre Pyramid, the Khufu or the Great Pyramid, the Red Pyramid, the capstone found next to the Red Pyramid, which was 1 meter high before it was essentially vandalized in between 2005 and 2008. We have the Bent Pyramid, and we have the Pyramid of Meidum. So let's begin with the Lucas numbers, and we begin with that spiral of 11 wide by 7 high. Khufu, or the Great Pyramid, is 280 Egyptian royal cubits high by 440 Egyptian royal cubits wide at the base. That creates a 7:11 ratio. The Pyramid of Meidum is 275 Egyptian royal cubits at the base. Now we know that because there's enough of the base left to find the angle. Measured by Petri, so we know the base length, and we also have the angle. We can extrapolate, and we get the 7:11 ratio of that pyramid as well. And the 1 meter high by 3 Egyptian royal cubits wide capstone, which was vandalized and next to the Red Pyramid, is also at a 7:11 ratio. So we have these Lucas numbers to begin with, describing 2 of the pyramids, and this very important capstone. And the meter and the Egyptian royal cubit share a lovely set of geometrical metrological connections, the essence of it. And if you express the Great Pyramid as meters, you also get beautiful, perfect, exquisite geometry and metrology, universal constants. Now this 7:11 ratio also creates the great problems of antiquity, include squaring the circle, doubling the cube, trisecting an angle, and the heptagon, or the 7-sided polygon. These are some of the 4 problems of antiquity. But this 7:11 ratio is a great approximate of squaring a circle. The Great Pyramid, now, which also leads us to phi and pi, beautiful numbers of nature. Nature insists upon it. This is not a human construction. It is built into nature, and from the 7:11 geometry of these pyramids. We also get a wonderful, very, very close approximate of the size of the Earth in relation to the size of the Moon via squaring the circle, via pi and via phi. And it also happens, mentioned in earlier episodes, we'll be revisiting this, but we also have the barycenter, the point at which the Moon orbits the Earth. The same geometry leads us to that. Now that just happens to be essentially 5,000 kilometers from the surface to below the Earth. Exquisite, beautiful, repeated numbers over and over again. Geometry, geo, Earth, metry, measure. This connects to this esoteric occult theme of the great architect. One thing leads to another, everything is connected, and through the quadrivium, especially arithmetic, geometry, music and astronomy, the essential sciences. Now even we see the Vesica reflected in here. This goes back a very, very long time, and it is a series of wonderful, connected, beautifully harmonized bits of information which describes so much. One thing leads to another, everything is connected. Indeed it is, and no less so than at the Great Pyramids of Egypt. We've touched on the 7:11 ratio, quite a bit to go, but the next would be the 7:4 ratio, which is a nice expression of the Egyptian raw cubit. All of the pyramids, or the old kingdom of Egypt, is linked by the Egyptian raw cubit of 0.5236 meters, or pi over 6 meters. The royal cubit is divided, as again, cubit rods exist. We know how they work, the hieroglyphs, etc. So each cubit was divided into 7 palms, and each palm was divided into 4 fingers, just like the modern system. And that's a nice 4:7 ratio, but the Egyptian raw cubit from elbow to fingertip, that's 1 cubit, which was then divided into 7 palms, and from the wrist to the elbow was 4 palms. There's a 4:7 ratio there. So much more information in regards to this and how it connects to the meter, the allegedly modern English foot, and the Egyptian raw cubit. We'll go more into that because this all links to time, and it also incorporates this beautiful series of margins of error in the pyramids lead us to higher levels of information. You keep counting and adding each time you have to add another magnitude of order of improbability, and these things keep building up. And we'll come back to this because this has really got to do with time, pendulums, and how these units of measure all connect, and especially through the Vitruvian man. Man is the measure of all things. So 7:11, the 7:4 ratio, and now we have the 3:4 ratio of the Lucas numbers. We'll turn that to the side and highlight it so we see 3:4. Now this links to Khafre's pyramid, 274 Egyptian raw cubits high, or 137 times 2, and 411 Egyptian raw cubits wide at the base. So that right angle triangle which defines Khafre's pyramid is 4:3. Therefore, that's a 3:4:5 ratio, which is the first of the perfect Pythagorean triplets. A squared plus b squared equals c squared, 3 squared plus 4 squared equals 5 squared. Pythagorean theorem is immeasurably valuable. You cannot you cannot underestimate how important it is. Now it just so happens that the King's Chamber, from the corner now, the floor of the King's Chamber is a bit of shenanigans going on in there. The oldest descriptions describe a narrow channel running around the outside, so what you have is 2 heights, but the height from the very bottom creates a 3-4-5 triangle. There's other beautiful geometry going on in there, but that's just another example of the 3-4-5, the first of the perfect Pythagorean triplets. This can be, I've done some videos on it, so you find it in Pythagorean Theorem and the Pythagorean triplets pretty much all around the world, across time, cross world, ancient cultures, just embedded it all the time. So the Khafre and the Khufu pyramid, or the Great Pyramid, 3-4-5 triangles. Pythagorean Theorem. Now a quote from Kepler. Geometry has 2 great treasures. One is the Theorem of Pythagoras, and the other is the division of a line into extreme and mean ratio. The first we may compare to a measure of gold, the second we may name a precious jewel. So Pythagorean Theorem, a squared plus b squared equals c squared, and here we have the division of a line into an extreme and mean ratio. This relates to phi, the golden number, the golden mean, the divine proportion. Many names given to it, but phi, just like Pythagorean Theorem, is, well, it's beautiful. It's beautiful geometrically, it's beautiful mathematically, and it is built into nature, and we'll examine that more. Now Kepler's 3 laws of planetary motion are another example of these wonderful harmonies, synchronicities, beautiful simplicity in regards to planetary motion. So the first law of Kepler, that all orbits are ellipses. The second law, equal areas in equal time. So 6 months equals 6 months. It's a beautiful harmony. It's describing a wonderful balance in the nature of things. Now, or an ellipse, let's just call that a shape, equal time and area, and we also have time in regards to orbits and semi-major axis. These are the laws built into nature. They are wonderful, they are geometric, they all connect, and we'll find these embedded in the pyramids. Of course, this is not limited to the pyramids, so whether it's stone circles in the UK, Karnak and the megaliths in France, basically all across the Mediterranean, ancient India, we see the same geometry, the same proportions, the same metrology, the same inherent beautiful natural knowledge embedded in these temples. Now, the official history will say they're all unconnected, therefore it must be coincidence. Keep adding up the probabilities and adding them, and the improbability of this being a coincidence is not even worth mentioning, to be blunt. Now, sticking with the 3, 4, 5 triangle and the Lucas numbers, Pythagorean Theorem, now let's introduce the Fibonacci numbers. Why are Fibonacci numbers so important? So Fibonacci numbers begin with 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8. Now this just might be a mathematical curiosity, not worth mentioning, but there's so much information in there. Now we can represent it as geometry, or we can do it via number and arithmetic. Also worth noting, 55 is the 10th Fibonacci number. It's also the 10th triangular number. 144 is the 12th Fibonacci. It's also 12 squared. There's, again, an exquisite series of connections between these numbers and the esoteric and architecture, both ancient and modern. Just exquisite. Now, Fibonacci numbers come from Leonardo Fibonacci. He's famous with, in the West, popularizing the Hindu Arabic number system. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, 10 is just 1 with a 0. We begin a new series. Now, that's one of the beauties of this base 10 number system. We have, including the thumbs, 10 digits on our fingers. It's, again, built into nature. The triangular numbers, 1 plus 2 plus 3 plus 4 equals 10. And that has to do with the Tetractys and the Tetragrammaton, which relates to Enoch, relates to Pythagorean schools as well. Now, another very interesting thing about the Fibonacci numbers. So if we 1 divided by 1 is 1. Okay, 2 divided by 1 is 2. 3 divided by 2 is 1.5, etc., etc. And what happens is the further you go down, the closer and closer you get to the golden number, phi, the golden mean, the divine proportion, all sorts of names. 1.618033988, etc. We get closer and closer the further we work down the Fibonacci numbers. Now this also connects to the Lucas numbers. It's basically built into maths. Anything that grows this type of way will lead to phi. But the Lucas and Fibonacci numbers are unique in the way that they are connected. But in nature, for example, what you'll find is passion fruit, 1, 2, 3, 4, 5, and 1, 2, 3. Now these are Fibonacci numbers. Flowers again will have 5 petals. Now 5 petals leads to the pentagon or the pentagram, which is just the most perfect representation of the golden number. Not just in trigonometry, but also in the proportions of each side of the pentagon and the pentagram is just phi. It's just beautiful. Now 8-petaled flowers, 13-petaled flowers, 21 petals per flower, Fibonacci numbers, which brings us to sunflowers, which are one of the most, sunflowers are just exquisite. It's like puppies, kittens, and rainbows. Sunflowers are just awesome. But they're also one of the best geometric, mathematical expressions of Fibonacci numbers, which of course leads to phi. Now, for instance, of course there are always mutations in nature. Just like the elliptical orbits, no orbit is perfectly circular. There are always mutations, eccentricities, elasticity, but as a very, very good rule, generally there might be some muted sunflowers which have 35 or 33 petals, but sunflowers will have either 34 petals, 55 petals, or 89 petals. Fibonacci numbers. Now the seeds inside the Fibonacci, inside sunflowers, are also defined by this Fibonacci spiral, Fibonacci numbers 34 and 55. Again, it's built into nature. This is not some mathematical curiosity just invented by man. Nature insists upon it. In all sorts of ways you will find the Fibonacci numbers expressed in nature. It really truly is natural. Now pine cones are arranged via Fibonacci spirals and the Fibonacci numbers themselves. You'll find it in all sorts of plants. Pineapples is another example of perfect Fibonacci numbers. You'll see it in cacti. DNA, okay, so DNA spiral, 34 angstroms by 21 angstroms. Now, angstroms relates, curiously enough, to the metric system. Okay, that's curious enough. We'll get back to this because foot, meter, and Egyptian raw cubit, exquisitely connected. 34 and 21, these are Fibonacci numbers. Now, the gap, that's the double helix, is also at 13 to 21 angstroms. 13 to 21 Fibonacci numbers. It is literally built into our DNA. The geometry, the beautiful proportions of these things. Now it's also, you'll find the golden number or the divine proportion via Fibonacci numbers built into the human body in so many ways. So for instance, we have, including the head, we have 5 appendages. Now just like the leg or the foot, the leg or the arm is also then divided into 3 units, and then we have 5 fingers. So forearm, upper arm, the forearm, and then the hand, 1, 2, 3, and then the hand itself is divided into 1, 2, 3, 4, 5. The bones in the hand are also related to the golden number. Again, this is just one expression. There are so many expressions of the golden number, the divine proportion in the human body. Just do a search, golden number, phi, human body. It has to do with the way things grow. Again, nature demands it. And the Fibonacci is probably the best expression of it. The Lucas numbers is another great one, but the Fibonacci is the best one to, if you're new to it, to examine. And again, if we examine the Fibonacci numbers, the more we go down, the closer and closer we get to the golden number. Now it's interesting in regards to the golden number and the way things grow. Just like Vitruvian Man, and this relates to the omphalos or the navel stone, which is a thing in architecture and city design going back to ancient times. The omphalos stone, for instance, in Rome, Temple of Apollo in Delphi, the Benben stones in Egypt. But the navel being the center of the circle in Vitruvian Man. On the grown adult is a ratio of 1 to phi, the golden number. However, at birth we begin at a 1 to 1 ratio. So you grow from a 1 to 1 ratio into a 1 to phi ratio. Again, and other people have noticed that it seems to be a pattern in stock markets as well. 6.18, 1 divided by phi equals 0.618. Phi is 1.618. Phi plus 1 equals phi squared equals 2.618. This is phi, 1 divided by phi squared is 0.328. It can be found in the way that branches grow on trees. The proportions of dolphins. There are many, many sites that go into all of these things now. There's a series, documentary series called The Code. It's all about maths. There's a particular episode all about spirals, and he goes out of his way not to mention phi throughout. Very interesting. He talks about spirals and the growth patterns and does not mention phi. Link in the description to Arthur Benjamin because he doesn't shy away from the beauty and simplicity of Fibonacci numbers. Whether it's Devlin or De Sautoy here, I can say I can't explain why they go to such lengths to disparage or dismiss or try and disprove phi. It just is a fact, and it's just curious why certain gatekeepers go out of their way to hide, I can't say it any other way, hide this fact, this beautiful fact, this inspirational fact of nature. when it comes to the Fibonacci numbers and the Fibonacci spiral and the way things grow. Horns, such as goat horns, would be another example of it. Now, back in the day, it was one of my favourite shows back then was Fringe by J.J. Abrams, and in the cards in between the ads, for instance, well, they have the goat horn. You might notice 1.61803398997, etc., etc. The golden number is shown in this particular show. Now, the show itself has multiple references to the golden number, or phi, for instance. Frog with a PH is another one of these examples of the golden number used in there. I'll put a link in the description. J.J. Abrams' Hidden Hermetic Themes of Lost, Fringe, Alias, and Star Trek. In these shows and movies, he embeds them with very familiar themes, mathematical, geometric, especially hidden in plain sight. Now, when it comes to the golden number, or phi, there are different symbols for it, but there we have one, and here we have another one, 1.6180333, etc. Well, what do we have in Disney? In red, and the dot above the I, very reminiscent. Now, okay, maybe that might be coincidence, but we need to go back to 1959, I think it was re-released 1961, An Adventure in Mathmagicland, or Donald Duck in Mathmagicland. Kids show, but great stuff because it talks about Pythagorean schools, the golden number, Pythagorean tuning. It's actually amazing for the time. You couldn't get away with it now. But I'll put the link to that particular show in the description because it's full of the wonders of math and the golden number, Pythagoreanism, the pentagram. Now, however, this is a repeated theme. So, not a couple of years ago, there was a series called Dig. Wasn't too bad of a show, in my own opinion. But what I noticed was that one of the main characters, a detective, they would show the number plate of his car repeated. Now, screen cinematographers don't just point the camera randomly. There's usually some sort of set design. And even though it was only for a glimpse, they would repeatedly show the number plate of a car, 1618. The golden number, 1.618033988, etc. And if you watch the show and pay attention, once you're aware of it, you'll see how, just for a fraction, I'll just move the camera across. Sometimes linger on it for a second or two, but, well, okay, interesting. Coincidence, let's just say. Now, it's an interesting in how often this appears. So, only a couple of weeks ago, not a bad movie again, Edge of Tomorrow. And it struck me, well, because there were 618 million drone aliens for every alpha alien. Now, how does that relate to the golden number? Well, phi is 1.618033, 1.618. Phi squared is phi plus 1, or 2.618033. That's why one of the reasons why phi is such a lovely number. Phi squared equals phi plus 1. Now, 1 divided by phi equals phi minus 1, 0.618033. 618. Now, that on its own, well, it's also interesting that the movie culminated at the Louvre Pyramid in France, at the Louvre in Paris. Well, the Louvre Pyramid is a scale replica of the Great Pyramid, which incorporates 5, 7 to 11 proportion, just like the Meidum Pyramid, just like the capstone next to the Red Pyramid. And although reluctantly, in an interview, I.M. Pei, the architect of the Louvre Pyramid, and some very other interesting buildings which just happen to have this repeat of these, let's just call them sacred numbers, mentioned that the golden section was one of the most important things, or maybe the most important, but if not one of the most important things he had ever learned. It really is hidden in plain sight. Now, once you start noticing these things, the way that cinematographers and artists repeat, now I could go into a whole list in regards to phi. I've done some videos in the past. It is just, either it is built into our DNA and we subconsciously lean towards it, or there are those who know, but a bit like Devlin or de Sautoy, these, let's just call them, I don't use the word gatekeepers, I'd say mainstream mathematicians. they either have an outspoken dismissal of phi or a very curious silence in regards to it. Even when they talk about spirals in nature, they do not mention it, which is curious. Others do, and phi is one of the most important numbers that you've never heard about. But that's an example. Now, it's in nature, like shells would be one example where we see the spiral, snails as well. Now you also see it on the micro, which is smaller than them, but you also see it on the macro because hurricanes also will share this same spiral, and not to mention galaxies as well. Now again, going to the micro, let's go to the Mandelbrot set, the M set, Fractal Geometry. There's a number file video which where I learn about this, but it's the number of tendrils, the little arms that break off the Mandelbrot set, are arranged according to the Fibonacci numbers: 2, 3, 5, 8, 13, 21. 2, 3, 5, 8, 13, 21. This M set, or fractal geometry, is sometimes also called the thumbprint of God because it's so important into the way that nature is organized. If you just look up M set or fractal geometry, and the beauty of it is the further you zoom in, this thumbprint of God, as it's called, just keeps getting repeated. And you just zoom in and it repeats and it repeats and it repeats. Again, it's a constant. Now, there's another interesting thing in regards to miles, kilometers. Again, the foot, the meter, the cubit, and the Fibonacci sequence. So 80 kilometers is essentially 50 miles per hour. 80 kilometers, 50 miles. The thing is, you can use the Fibonacci numbers as a good example of a conversion point between miles and kilometers. So for instance, just drop to 0, 8 and 5. 8 and 5. Now let's be a little bit more accurate. 2 miles equals 3.2186 ... kilometers. 3 miles equals 4.828 kilometers. Again, very close to 5, and a good approximate, not super accurate, but still very easy way to convert it. 5 miles equals 8.046 kilometers. 8 miles equals 12.87, essentially 13 kilometers. Now you can do the reverse as well. 144 kilometers equals 89.4774 miles. This is just a curiosity on the side, but geometry, geomeasure, and the relationship between man, the measure of all things, symmetry in temple designs as described by Vitruvius, and the lovely relationship between meter, Egyptian royal cubit, and the allegedly modern English foot, which can be found in ancient Greece, for example, and also lovely connections. We'll explore this more because this has a lot to do with timekeeping, especially for 1 second pendulum. So whether it's Nuwa, Fuzi, Hermes or Mercury, Greco-Roman or Thoth and Chesed, they're the gods of geometry, they're the gods of measure, gods connected to science, alchemy, architecture, but weights and measures. Geometry, metrology. So back to the Lucas numbers, and we had the 3 to 4 ratio from the Lucas numbers, which describe the right angle triangle, which describes Khafre's pyramid, which creates a 3, 4, 5 triangle, all in relation to Fibonacci numbers. So we have a Fibonacci spiral. Now Kepler, important. Now geometry has two great treasures. One is the Theorem of Pythagoras, a squared plus b squared equals c squared, and the other, the division of a line into extreme and mean ratio. The first we may compare to a measure of gold. The second we may name a precious jewel. This has to do with the golden number, and which of course is embedded in the Lucas and the Fibonacci numbers. So Fibonacci numbers, that for instance begin with a square 1 to 1, then we have a 1 to 2 rectangle, then we have a 2 to 3 rectangle, then a 3 to 5 rectangle, and then a 5 to 8 rectangle. Begin with the 1 to 2. Well, we already saw Pythagorean Theorem inside the upper or the king's chamber of a great pyramid. Well, the length of it is 20 Egyptian royal cubits and the width is 10 Egyptian royal cubits, a 2 to 1 ratio. This will again shows multiple links between multiple pyramids, etc. Now, to the Fibonacci numbers again, for 3 to 2 ratio, again, the Vesica is incorporated in there. We already saw the Vesica as an excellent beginning point of the Lucas numbers, and the 3:4 ratio being essentially a Vesica cut in two. And 3:2. So Khafre's Pyramid, 411 Egyptian royal cubits wide by 274 Egyptian royal cubits high, is a 3:2 ratio, the Vesica or the Fibonacci Spiral, which again links us back to the 3:4 of the Lucas numbers, which links to the King's Chamber or the upper chamber, which is at a 2:1 ratio as in Fibonacci numbers, and that links with Khafre's Pyramid through the 3:4 and, well, the 2:3, a nice crossover point. So Fibonacci numbers, Lucas Spiral, Khafre's Pyramid. So let's look at the bent pyramid. The red pyramid. Now the red pyramid is the top port. It's the same geometry. The top portion of the bent pyramid is the bent pyramid, and these are next to each other. Red pyramid geometry is reflected in the top portion of the bent pyramid, and they just both so happen to be 200 Egyptian royal cubits high. Now some will say that this was because there was a change because of a problem in construction. Well, it just so happens that the geometry, which we'll examine looks shortly, but the height of these were exactly the same. So yeah, interesting. Now it just so happens that Menkare's pyramid is 200 Egyptian royal cubits wide. So we see the same measure going around. Now if you examine the other, as they're called, unfinished pyramids or other partly demolished pyramids, what you'll find is that 100 Egyptian royal cubits or 50 Egyptian royal cubits is essentially a standardized measure. So there's a lot of other pyramids to mention for Ameni-Kamau, which is at a 3:4:5 ratio, just like Khafre's pyramid, but also this use of 100 Egyptian royal cubits as a standard for the base width of these many other pyramids. Now, so the bent pyramid, the top section, is a reflection of the red pyramid. So if we were to extend those lines down, they would be a exact replica of one another, and they're exactly the same height. And the red pyramid is 420 Egyptian royal cubits at the base. So if this line was extended, so would the bent pyramid, 420 Egyptian royal cubits. Now, which brings us back to the Fibonacci series, 3:2, and Khafre's pyramid. Well, the Great Pyramid is 280 Egyptian royal cubits high. Now that's 6 Egyptian royal cubits between these, which just happens to be pi meters, but we'll get to that later. So 3:2. So the Red Pyramid, 420 Egyptian royal cubits at the base. The Great Pyramid, 280 Egyptian royal cubits high. That's a 3:2 ratio. So the same geometry, which describes Khafre's pyramid and the 3:4:5 triangle via the Vesica Pisces and the Fibonacci numbers, also shows a proportion between the Great Pyramid and the red, also the bent pyramid. It's lovely links, you know. Now, on their own, what we have is, well, again, a series of connections which links multiple pyramids in multiple formats, just like the Lucas numbers, and we examine more, it's the Fibonacci's as well. So Lucas numbers, Fibonacci numbers. So I've listed here the Fibonacci numbers. Now what happens if you divide Fibonacci number 2 by Fibonacci number 1? You repeat that pattern, as we saw earlier. It brings us closer and closer the further you go to the golden number, phi, 1.61803339, and that's, again, the golden number, golden ratio, or phi, which describes so much of nature, just a beautiful, perfect number, unique in that phi plus 1 equals phi squared, 1 divided by phi equals phi minus 1. So many other connections to that. It's just beautiful. Now, if you do the same with the Lucas numbers, we list them and we divide them, the second by the one previous, very, very quickly we get to the golden number, 1.61803339, which is built into any sequence that follows this pattern. But there's a series of unique relationships between the Lucas and the Fibonacci numbers. So in regards to Fibonacci numbers, Lucas numbers, and the golden ratio. I'll put a link in the description. I posted it as part of, I included it in the playlist, but I gave it the name Fibonacci, Phi, Fibonacci, Lucas, square root of 5, and the pyramids or the PHIramids. And so that also will be linked in the description because of a very curious relationship between Phi, the Lucas numbers, and how the Lucas numbers have a wonderful connection to the Fibonacci numbers as well. So really mention, okay, the pentagram or the pentagon is a perfect geometric expression of the golden number. It's to write it as a fraction in, I'm not sure if it's actually transcendental or just purely irrational, but it's very similar. It's very similar to pi in that the decimal places go on for a very, very long time, if not forever. Square root of 5 being also a very nice way of calculating the golden number, and also how the angles link in trigonometry to various expressions of phi as well. The Vitruvian man, or human form in general, from the belly button to the soles of your feet would be the golden number, phi, 1.618, and from your belly button to the top of your head would be 1. So this is another, the golden mean, golden ratio, which brings us back to the red pyramid and the bent pyramid. Now the top part of a bent pyramid, now they're both of the same height, 200 Egyptian raw cubits, which is the width of Menkaura's pyramid. But the interesting fact about this particular geometry here that I've highlighted is that if you were to unfold the sides of the pyramid down onto a two-dimensional plane, you would create these the pentagram or the pentagon. Lovely geometry connected to the golden ratio in there as well. So, well, of course, the Great Pyramid, now there are different ways to do it, but from the tip down the slope, in regards to the half base, is phi to 1. If you include the ideal measures, it's a very close approximate of it. If you include the actual measures and variations in each side, it's essentially perfect. Now, that same geometry can be found in the Maidum Pyramid, also in the 1 meter high capstone found next to the Red Pyramid. Again, multiple pyramids linked through this very beautiful, very simple, but profound geometry. It sort of brings us back to Mario Livio. Golden ratios inspired thinkers of all disciplines like no other number in the history of mathematics. It truly is exceptional. Now, the Kepler Triangle, this triangle is a pure phi triangle, and it's creating the geometry that describes the Great Pyramid or the capstone or the Maidum Pyramid. And again, as Kepler, geometry has two great treasures, the Pythagorean Theorem and the divine proportion, the golden mean, the golden ratio, or phi. That's one, that's as a line, you see the example, because the small part is in relationship to the large part, as the large part is relationship to the whole. Again, only with this particular number. That's why phi equals phi squared equals phi plus 1. 1 divided by phi equals phi minus 1. Alright, 3, 4, 5 triangles, Fibonacci numbers, and how these link as well. Okay, we've done that, the 2-to-1 ratio. Okay, I'll put the link in the description because using the Vesica, it's also a great way to create a 3D model of the upper chamber as well. I've also done a few videos on how to, again, on a piece of paper to draw the geometry and then to fold it together and to make Menkaura's pyramid, Khafre's pyramid, and the Great Pyramid as well. But the 3-to-2 ratio, Vesica, Khafre's pyramid, those links. Now here's the interesting part as well. So the Vesica will divide into an equilateral triangle, as we saw in Proposition 1, Book 1 of Euclid's Elements, and we'll also create an equilateral triangle in that format, which is the relationship of 1 to the square root of 3. So the Red Pyramid is a folded pentagon. The top of the bent pyramid has that same geometry. They're both 200 Royal Egyptian cubits high, but the bottom part of the Red Pyramid is equilateral triangles. So if you were to unfold the bottom portion of the bent pyramid, you would create a series of hexagons. Hexagons, the Vesica, the seed of life. This beehive geometry, essentially. So pentagon on top and an equilateral triangle on the bottom. So we have, again, unfold the top, you get a pentagon or a pentagram. Unfold the bottom portion and you get a hexagon, which is a sixes and fives, a five-sided polygon and a six-sided polygon. Just so happens that the Great Pyramid, 280 Egyptian royal cubits above ground, but if you include the subterranean, that's 336, a 5 to 6 or 6 to 5 ratio happening again. So we have a nice link, and there's the Delium problem, or doubling the cube, one of these problems of antiquity, is also embedded in this. We'll do that in the future. Alright, so while we're here, I'll put, I did an animation on this. I'll give it a second to unload. So there we see the bent pyramid, and just to see it in an animated format. So if you take these 5 pentagons, fold each one up, you create the top portion of a bent pyramid or the entirety of the red pyramid. Skip a little bit forward. Okay, so that's the red pyramid or the top portion of the bent pyramid. And of course the bent pyramid is sixes and fives, a hexagon and a pentagon. This will be linked in the description as well. So there we see the pentagon, and now we have the hexagon, which is the seed of life. Let's go back a moment. Because, okay, there we see it, just for a glimpse, the seed of life, which creates the hexagon. And of course this is as found in the Osirion, studied by Da Vinci and others. It's found again cross time, cross cultures, across the world. If you were to fold these up, you would get the bottom portion of the bent pyramid. Alright, so, well, because it's an equilateral triangle, that creates the top half of an octahedron, one of the 5 Platonic solids, which of course is like the Star of David hexagon pattern. In case you missed that, if you view that in 3 dimensions, the octahedron, just like the cube creates a hexagon, if you look at it at a certain perspective, so does the octahedron. And so we have again 6s and 5 and 1-dimensional measures, 2-dimensional geometry and 3-dimensional geometry, and also when you bring in the perspectives of it. So the top half of an octahedron would describe the bottom portion of the red pyramid. That'll be linked in the description. Okay, back to the images. So these are some of the things that are happening in the pyramids and how they are linked in multiple formats in all sorts of different ways, but from the same basic geometric constructions, and the Fibonacci and the Lucas numbers being one way to describe that. So the next Fibonacci 5 to 8. Okay, so Menkaura's pyramid, 125 Egyptian royal cubits high, 200 Egyptian royal cubits wide at the base on its longest side. None of the pyramids are perfect squares at the bottom, and this imperfection actually leads to a series of lovely geometric metrological perfection. Go into that more in the future, but at 5 to 8 ratio. So Menkaura's pyramid is at a 5 high to 8 wide. Now because the red and the bent pyramid are 200 Egyptian royal cubits high, we have that same 5 to 8 ratio. If the height of Menkaura's is 5 high, then both of these are 8 high, 5 to 8, same thing happening. Which brings us back to the Khufu or Great Pyramid and the Pyramid at Maidum, which share the same 7 to 11 proportions as in squaring a circle and so many other aspects, again more in the future in regards to that. And it just so happens, for instance, at Great Pyramid, 280 Egyptian royal cubits high, the Maidum Pyramid, 175 Egyptian royal cubits high. Now whether it's the height or the base length, we still get a 5 to 8 ratio. So just like Menkaure, red and bent pyramid, Khufu and Meidum pyramid, same thing. Okay, now my computer's freezing up. Let's try and simplify that. Okay, yep, get that out of the way. Hopefully that'll fix it. We've seen the Lucas numbers. We've looked at the beginnings of the Fibonacci spiral and how they connect and join, again, multiple pyramids joining in multiple forms through this, essentially a very small collection of some very simple yet profound geometry, which just goes to describe so much of nature. So in various formats, Menkaure, Khufu, bent pyramid, red pyramid, bent pyramid, Meidum pyramid, joined by this 5:8 ratio. Just so happens that Vitruvian Man, that the radius of the circle enclosing Vitruvian Man is 5 to the edge length of the square being 8. Another example of this 5:8 ratio. So Fibonacci numbers, the Lucas numbers, describing quite a bit. And as we just click back through, and very simple, very elegant geometry which describes again so much of nature, the basic forms of Euclidean geometry being expressed in so many different ways, including, well, other examples of it, but also the Platonic solids. Pythagorean Theorem 5, a golden mean. Will be, all these links mentioned will be in the description, and we see it in so many formats, and again throughout time the greats of architecture, Hermeticism, astronomy, geometry consistently and repeatedly talk about the same themes. Now, we don't have ancient Egyptian texts describing this, yet the stonework is a textbook in stone. So what is the quotes by attributed to Pythagoras or Plato or Kepler or others is expressed through architecture, and again measurable, testable, and it's these numbers, these geometric forms which are so essential to describing so much of nature, and linking not just one, not just two, not just three, but multiple through these, again, the same forms, joining, linking, connecting, metrology, geometry. And just to click back through, and yeah, Thoth, Sheshet, Hermes or Mercury, Nuar, Fuzi, guides of architecture, geometry, astronomy, weights and measure. And again, this the applications for it in various forms, whether it's the Fibonacci focus here, but also the Lucas numbers, again expressed in the microcosm and the macrocosm. For microcosm is what is small of a man, for macrocosm is what is large of a man, and we see these expressions repeated throughout, and how it also pops up in the media. So is this hidden in plain sight intention? Is it built into our DNA? Well, it literally is built into our DNA. It's built into the way nature forms. Stock markets is another example of this chaos, which seems to have a connection to geometric forms throughout, like, yeah, literally in our DNA as well. So how deep that goes, who's to say? I can't, I have no way of proving that, but it is measurable in the modern architecture, in the ancient architecture, and in nature itself. And yeah, so sunflowers and animals, and the plant world, the animal world, the cosmos, in hurricanes, typhoons, or cyclones, as they're called, especially through the golden number, geometry, arithmetic, astronomy, music, especially things like Kepler's laws. This is, there are laws to this, that are repeated, measurable, tangible, and they just so happen to be repeated in the pyramids. Other ancient structures, you'll also find it in cathedrals and secular modern buildings as well, whether it's a US Capitol building, or Frank Albo, especially focused on the Manitoba Legislative Building in Winnipeg. Again, the same themes, geometric, astronomical, arithmetic, and musical themes connected to Hermeticism. So whether it's Treatise on Weights and Measures, this ancient text, whether it's Vitruvius, these other Greco-Roman texts where we have very clear, very readable textbooks, but also translating into architecture to ancient Egypt, or even in Babylon and the clay tablets, which include the square root of 2 to a very high precision, and the linkage between these things. So now, whether you're of a spiritual bent or not, at the very least, as a concept, the idea of a great architect is a very convenient one. Now, I don't like to talk about that because I don't want to promote any sort of, let's just say, religion. It's not, that's up to you. But geometrically, we can measure it. Through metrology, we can measure it. It is repeated. It is built into nature. It's not something that you can just make up. This is if you count the facts of this and then even do a very conservative estimate of the probability of this being a coincidence, well, you're really stretching it to say that it should not, at the very least, be something of interest. Now, proof is a strong word, but that something is at least worthy of interest. And even if it was possible to prove that this was purely coincidental, then at the very least, this is a beautiful system of education. Because if you learn some basic drawing techniques, some basic arithmetic, you're not only describing ancient architecture, but you're also describing so much of nature. And previous episodes went into the planets and the sun and the moon and the earth. And again, it's by pure coincidence or whatever, or by design. At the very least, there is a very simple yet complex, beautiful, sophisticated, yet easy to perceive system that is, well, at the very least, educational, if not a deliberate attempt by ancients to preserve this knowledge, a textbook written in stone to survive the ages. Now, you only have to be around for a short time to realize that papyrus scrolls will decay and will be lost. That language, in one generation, words change in their meaning. So even like the spoken language can be lost in translation. But through measurement, through geometry, through geodesy, geometry, earth measure, and some inherent proportions, some universal fundamental rules of nature, such as, well, geometry, you can encode this knowledge, and if you write it in stone, it's there for the ages. And, well, again, repeated cross time, cross cultures, across the world. It's to try and design this. If you were a computer whiz kid and you would try to design some sort of sim city to follow these laws, well, it's just beyond reason. And so, yet when it comes to the architecture and the geometry, well, it's there to be measured, and I can't stress that enough. It's there to be measured. It can be measured. It can be repeated. If you apply this to other pyramids, so the so-called unfinished pyramids in Egypt, or you were to apply it to other ancient architecture, the Parthenon, so many of them, stone circles, Karnak megaliths in France, the stone ships up in Norway, ancient Indian temples, Hindu temples, cathedrals of the Gothic era, repeated and consistent. And so there we can draw geometric links between the pyramids. And I think it's up to the skeptics to try and come up with a method of how this coincidence can be so balanced, let's say. There's the evidence, there's the data. You can check the surveys, you can check the geometry, you can, really please do double check it for yourself. There is a connection here, whether it's in our DNA, whether it was by design, or whether it was by pure coincidence. Doesn't really matter. The fact is that it can be measured, it can be tested, and forms at the very least, an educational system where we should be taught this. Because in the last few years that I've studied this, I've learned so much about my interest in math and geometry was rekindled, my interest in astronomy, music theory. Oh, yeah, it's just presents itself to me as where the education system I went through, I come out of it at the end. I couldn't tell you anything about the sun or the moon or the earth, even though I did my science classes in high school. I did not too bad in math. I did not too well, and I really couldn't tell you too much. Yet here it is. Anyway, I could rant and rave about that, but please double check, triple check. It's there to be seen. Like, share, comment as you feel necessary, but this is there is something to this. I can't explain the origin, I can't explain why, but it is there and it can be measured. Have a good one.